The fundamental rule of calculus states that integration is the opposite of differentiation. Now, what does opposite mean? For example, when you differentiate x to the power n, where x is the variable and n is the exponent, we write the exponent first and multiply it with the variable, but reduce the exponent by 1. That means d by dx of x to the power 1 is, we write 1, and x to the power 0, which means 1. D by dx of x squared, we write 2 and multiply it with the variable x, and the power is reduced by 1. D by dx of x cubed, by that logic, is 3 multiplied by x squared, and on and on. In case of integration, what we do is, this is the symbol for integration, and we have some expression x to the power n dx. So that is the symbol for integration. And here, the first thing we do as opposite, we increase the exponent by 1, first of all, and then we divide, instead of multiplying, we divide by that increased exponent. That makes the logic like this. Integration of x to the power 1 is x squared by 2. Integration of x squared dx is x, increase the exponent by 1, 3 divided by that. Then integration of x to the power 3 dx becomes, increase the exponent by 1, x to the power 4, by that, by 4, and on. So this is how it works. So generally speaking, when we have differentiation for a constant, it actually means d by dx of a constant, we get 0. What it actually means is that d by dx of constant x to the power 0. So if you think of the constant and bring it outside the differentiation, and we just differentiate x to the power 0, so what happens basically is the 0 comes first, and then we reduce the power by 1, which is 0 minus 1 is minus 1, and the whole thing turns out to be 0. And that is true for every differentiation with a constant. So when we do a differentiation with any constant in front, so a x to the power n, we write the constant outside the differentiation. So what we do, we keep the constant outside and we just differentiate. We write n x to the power n minus 1. So by that logic, what we have is, when we have to integrate some constant, so ax to the power n dx, think of this constant as outside the integration, and that becomes a integration of x to the power n dx, and we can write a in its place, so this would be x to the power n plus 1 divided by n plus 1. So remember, when we integrate a x to the power n dx, we can think of this a constant outside the integration, and eventually it would be x to the power n plus 1 divided by n plus 1. So let's do a number of examples. So integration of 3x cubed dx. So the 3 would be in its place, so we don't have to do anything to this, so keep it here. So x would be increased by 1, so it would be x to the power 4 divided by that. So the answer would be 3 by 4 multiplied by x to the power 4. If it was 2 divided by x cubed, in that case, we cannot integrate unless we bring this variable upstairs. So it would be 2 multiplied by x to the power minus 3. So now it's a bit tricky. So what we have to do, remember, when you increase minus 3 by 1, it actually becomes minus 2. So divided by minus 2. So this 2 and this 2 cancels. It would be minus x to the power minus 2. What about exponents that are fractions, third form? So if you have integration of 5 square root of x dx, in that case you have to do int 5 multiplied by x to the power half dx, and this turns out to be 5 x to the power half plus 1 is 3 by 2 divided by 3 by 2, and that turns out to be 5 multiplied by 2 by 3, because 5 divided by 3 by 2 is 5 multiplied by 2 by 3, into x to the power 3 by 2, and the answer turns out to be 10 by 3 x to the power 3 by 2. One important rule to remember is the addition rule that we have in differentiation. We also have that in integration. The addition rule is that when you have d by dx of two variables either added or subtracted, it is the same as the individual differentiation added or subtracted. So that means if you have integration of two variables u plus v or u minus v, then we can write it as integration of u dx plus or minus integration of v dx. So that means the integration of the sum of variables is the same as the individual integration and their sum. That is known as the addition rule of calculus. So when we have something like that, if we have to integrate 2x cubed plus 5x squared minus 7x plus 3 dx. So this is the same as integration of 2x cubed dx plus integration of 5x squared dx minus integration of 7x dx plus integration of 3 dx. And again we can break it down as, if we bring the constant outside, 2 integration of x cubed dx plus 5 integration of x squared dx minus 7 integration of x dx plus 3 integration of dx. So this is if we further break it down. So this is what we can write by the addition rule. So when we integrate this, what we get, so we have 2 integration of x cubed is the exponent would increase by 1 divided by that exponent plus 5. So x squared would become x cubed by 3 minus 7, x would become x squared by 2 plus 3. So here dx, integration of dx is going to be x. So that's that. But there's one more thing I haven't mentioned. It's known as the indefinite integral. Whenever we are integrating, it is either definite integral or indefinite integral. So we have to be very, very clear about it, and we have to do each of the integrals in a specific way.